let's begin. We're going to move on to graphing vertex form parabolas. So very important stuff. Please pay attention. And let's begin by graphing this parabola right here, f of x equals x squared, using an input-output table. So let's all just do a quick xy table right here. And let's plug in some numbers like -3, -2, -1, 0, 1, 2, 3, and we'll stop right there, even though we could continue forever. Now, what do I mean by plug in? This is an input, it's an x value, and we put it in to the function f of x equals x squared. So when I take the -3 and put it in, what is -3 squared? 9 is absolutely right. How about when I plug in -2, what's -2 squared? 4, that's right. How about -1 squared? 1. How about 0 squared? How about 1 squared? How about 2 squared? How about 3 squared? Now, could I do 4? Yeah, right? I could plug in 4, I'd get 16. But since we are talking about coordinates here, I already know that 4, 16 is off the graph. I know that this graph is a 10 by 10 graph, so I'm not going to bother with plugging in 4, even though it does exist. I could plug in 5 and I'd get out a 25. I could plug in 10 and I'd get out 100. That would mean that the graph would exist at 10, but it'd be way up there off the graph at 100. All right? Anyway, let's graph the coordinate 0, 0. That's that dot right there. Let's graph the coordinate 1, 1. 1 on the x, 1 on the y. There it is. Graph the coordinate 2, 4. 2 on the x, 1, 2, 3, 4 on the y. There it is. Graph the coordinate 3, 9. 1, 2, 3, all the way up here to 9. And we did not graph 4 because it's off the graph. Anyway, let's go in the negative direction. The coordinate -1, +1, that would be right here. -2, +4, that would be right there. Coordinate -3, +9, it would be up here. Once again, -1, 1, -2, 4, -3, 9. And this is our parabola. Let's draw it carefully. It's not a v anymore. It's not an absolute value function. It's a U-shaped curve that we call parabolas. And that's how we graph parabolas, using an input-output table, which I do not recommend. Because imagine this. Imagine if we looked at this function down here, y equals x in parentheses -2, close parentheses, squared plus 4. Imagine me plugging in a 1 right in there. Then I'd have to do 1 take away 2 is -1. And then -1 squared, -1 times -1 is +1. And then +1 plus 4, that'd give me a 5. So I'd have to do a lot of math to find the coordinate 1, 5, right? Does that make sense to everybody? Yeah. So obviously, input-output table is not the best way to graph. Similar to absolute value functions, we have a form that we're going to memorize that'll make it really easy to graph these parabolas. And this is the form, vertex form. And the form is y equals a, parentheses, x minus h, close parentheses, squared, plus k. Now, if you're thinking, wait a minute, that looks very familiar to the previous absolute value function form. And yeah, you're right. This is the previous absolute value function form, and it also has the a out in front, and it also has the h right there, and you think opposite of h whenever you look at it, and the k value is also right there. So the vertex form of today, parabolas, is almost, it's very, very similar, almost identical to the absolute value function form that we learned a couple days ago. Everybody good so far? All right. Now, let's talk about how this parent graph would have been graphed a lot easier knowing the form. You see, if it's in this form, you're going to be able to identify the vertex HK. Now, I know that this parabola up here, you're thinking like, what the heck? I don't even see parentheses squared. I don't see an A. I don't see an H. I don't see a K. If you wanted to, you could put parentheses around the X just to kind of make it look like the actual form that we're memorizing, okay? And if you wanted to, you could rewrite this thing saying f of x equals, well, the a value is the number that's out in the front. And if there is no number out in the front, that would be a 1. And of course, we have the parentheses. And on the inside of the parentheses, we have x minus h. But as we could see, there is no h, right? That would be a x minus 0. Then you'd have squared and then plus k. But there is no number on the outside being added or subtracted. So that would be a plus 0 as well. So do you see how we made it look like the vertex form that we need to memorize? Yes. There it is, vertex form. We need to memorize that. Okay. So if I know this form, it'll be really easy to find the vertex. That would be h and k, which is 0, 0, which is right here, 0, 0. Now, the a value of 1 is not like the slope. Okay, it's not like the slope. Back when we did absolute value functions, if you had a 1 right here, you would say, oh, go up 1 over 1, and up 1 over 1, up 1 over 1, and it would be a v going like that. That's not the case here. Okay. The a value does tell you, just like in absolute value functions, it does tell you if it's a regular opening graph, or if it's wider, or if it's narrower, or if it's opening down. So the a value does do all those things, but we do not treat it like a slope like we did in the previous absolute value function section. Okay, so through this graph, there's also a line that I like to draw always in green. It's a vertical line going right through that vertex. Okay, you guys might as well just do a little dotted line right through the vertex. In this case, it is exactly your y-axis. But this little green dotted line, the name of it is called Axis of Symmetry. Axis of Symmetry. I don't know if that's too far away. There it is. Axis of Symmetry. And we're talking about that vertical green dotted line that crosses right through the vertex. Now, you guys remember from previous sections, how do we write an equation that ends up being a vertical line? Anybody? How do you write an equation that ends up being a vertical line? X equals, right? X equals. So any axis of symmetry will be this equation, x equals h. You need the x equals because that's the only way to get a vertical line, and it'll always be h. What the heck is h? H is the x value of your vertex. Okay? So this is something that we definitely need to know, that the axis of symmetry is the equation x equals h. Drawing it is easy. You just draw a dotted line going right through the vertex. But stating the equation of that vertical line, it's also easy. It's simply x equals whatever the x value of your vertex is. X equals h, right? It'll all come together in a couple of seconds. Okay? So before we actually get to applying all this knowledge, let's write down this knowledge. The a value, it tells us a lot. I mean, this is what I wrote down on my notes, posted on Google Classroom. It says, tells you if it opens up or down. Obviously, if the a value is positive, it's going to open up. If it's negative, it's going to open down. Also, a makes the graph wider or narrower, right? We kind of saw that already with absolute value functions. If your a value was 2, that was a narrower v than the a value of 1. If your a value was 1/2, it ended up being wider, right? So the a will definitely tell you the width and if it's opening up or down. The hk, we already know hk is what? X and y. Yes, but what's the name of that coordinate? Vertex. Vertex. Okay, so we know that for sure. Now, before we move on to h and k, I want to go back to the parent graph up here, and we call it a parent graph. The reason why we call it a parent graph is because all other parabolas come from this graph, right? If you're a parent and you have kids, your kids usually look like you, right? All other parabolas, doesn't matter if they're wider or if they're narrower, they're going to look like this, but they have gone through some type of transformation. Maybe it's opening down instead of up. Maybe it's wider. Maybe it's narrower, right? Now, with that said, if the a value is 1, this a value up here is 1, and it tells us the width. If the a value of the parabola that we're graphing is the same a value as here, which is 1, it's going to be exactly this perfect width of a U-shaped curve. Yes? Okay. Now, if this a value, let's say the a value would have been like, let's say 1/2, then that would have made it wider. I mean, this is not accurate, but it definitely makes it wider. If the a value is less than 1, it makes it wider. Okay. Likewise, if your a value is, let's say instead of 1/2, let's say your a value was 2. That would make it narrower. Your parabola would be narrower. Okay. We don't need to know that this week. We don't need to know that today or tomorrow or even on Friday. Next week for sure, we need to know how a value vertically stretches it, making it narrower, or vertically compresses it, making it wider. But I just want to throw those vocab words out at you right now just so you could start getting used to them and start understanding how the a value makes it narrower or wider. But anyway, if your a value is 1, it's going to be this perfect U-shaped curve, okay? So if we have a different vertex than this vertex 0, 0, like let's say we have the vertex, let's say 5, 0, okay? Let's say we have the vertex 5, 0. Don't write this down, 1, 2, 3, 4, 5, just look at it. Then if I had the h value of -5, it would move it over here, or actually +5, move it over here, and it'd be the same exact parabola, just shifted over to the right 5 units, right? So if you have different h or k values, all it does is relocates that parent graph, especially if your a value is 1. So the h value actually causes a shift either left or right. Likewise, the k value causes a shift up or down. Okay? And that'll all come very easy to you once you identify the HK. When you graph it, that causes that original parent graph to shift according to H and K. Now, what we do need to memorize is the pattern 1, 1, 2, 4, 3, 9. Okay, so everybody right now memorize 1, 1, 2, 4, 3, 9. A great way to do this is take your cell phones, change your password to 1, 1, 2, 4, 3, 9. Right? Definitely make your life a lot easier. Get used to it, memorize it. Now, what is this pattern? This pattern 1, 1, 2, 4, 3, 9 is amazing if your a value is 1. Okay? Now, it's not like some mathematician said, you know what, let's make up a pattern and have people memorize it. No. The pattern of 1, 1, 2, 4, 3, 9, it came from somewhere. It came from the parent graph. Right? This is the parent graph. This has the a value of 1. So we know that any parabola with the same a value of 1 will be exactly this width. It's not going to be wider. It's not going to be narrower. So if your a value is 1, you could use the pattern 1, 1, 2, 4, 3, 9. Yes, on the original parent graph, the 1, 1 was an actual coordinate. The 2, 4 was an actual coordinate. The 3, 9 was an actual coordinate. Does that make sense? But now we're going to be able to, whenever we have an a value of 1, because that's what our parent graph has, it has an a value of 1. Whenever we have an a value of 1, we'll be able to use the pattern 1, 1, 2, 4, 3, 9 from the vertex. So it doesn't matter where your vertex is at. If your vertex is right here, you're going to go 1 over 1 up and put a dot right there. Go back to the vertex 2 over 4 up, 3 over 9 up, and you'll be able to graph your parabola from that vertex without doing any math. So please memorize 1, 1, 2, 4, 3, 9. Okay? It's really awesome. Now, the pattern 1, 1, 2, 4, 3, 9 comes from that parent graph that has the a value of 1, and it works for the a value of 1 or even -1. If you had a -1, all you have to worry about is instead of going 1 over and 1 up, instead of going 1 over and 1 up, you'd be going 1 over and 1 down if your a value was -1, okay? And let me tell you this week we're only focusing in on parabolas that have that perfect 1, 1, 2, 4, 3, 9 pattern, only with the a value of 1 or -1, so that's great. The vocabulary right here, it's everything we've been talking about. We know what a parent graph is. It's y equals x squared. All other parabolas come from some type of transformation, change, modification of this original parent graph. What is a transformation? Maybe instead of opening up, it opens down if your a value is negative. It might get wider if your a value is closer to 0, or narrower if your a value is further away from 0, or it might move to the left or to the right, or up or down depending on your h and k. All that stuff that we've been talking about right now. We also talked about the axis of symmetry. That's the vertical line passing through the vertex, and it provides a reflection when graphing. You're going to love the axis of symmetry once we actually get to graphing. Now, another very important detail that's missing from this axis of symmetry definition is the actual equation for the axis of symmetry. So let's write this down. In addition to that definition, let's write down x equals h. This right here is the equation for the axis of symmetry. Anyway, let's look at number 1. And when we graph this, we first need to look at it like if it were in vertex form. So this is the form that we need to memorize. Vertex form. And in addition to the pattern 1, 1, 2, 4, 3, 9. But what's different about this compared to this guy right here? What are the visual differences? Anybody?
It doesn't have an H.
Doesn't have an H.
And an A.
Doesn't have an A. Doesn't have parentheses, right? So it could be a little weird when we're looking at this the first time. So I highly recommend, if you don't see parentheses, let's put parentheses, right? Now, the parentheses are not around the x with the square. It's only around the x. And maybe just by putting those parentheses, now you'll be able to see, oh, the a value in front, there's an invisible 1 right there. And then maybe putting the parentheses, you'll see, oh, the h value is the number that's inside the parentheses being subtracted from x, which means that h is what? That's right. And the k value is simply the value that's being added or subtracted at the very end outside of the parentheses. Take it for what it is, which is -4. So you might want to put parentheses around that x. You might even want to rewrite this whole thing. I mean, you don't have to, but you could rewrite it as y equals 1 parentheses x minus h close parentheses squared plus k, which is, that's a -4, not a +4. So -4 right there. So you could write it that way, or if you already could get all that information just by putting parentheses around the x, you're good to go. So anyways, now that we identify the a, the h, and the k, we could start with step 1. Everybody write down step 1 right here, the vertex. Just like before on absolute value functions, the first thing to do is to find that most important point. Let's do the same for this parabola. What's the most important point? It's hk. What is hk? What is the h value? 0? -4. Right? H is inside. We rewrote it right here. H, 0. K value, -4. So there's the vertex. Let's graph that vertex. 0, -4 is down here. That is step 1. You're going to do this first step just like we did first step on absolute value functions. You're going to do this as a first step on parabolas. Step 2, axis of symmetry. Okay, so let's all write that down. Axis of symmetry. Now, the axis of symmetry, to draw it, it's the easiest thing in the world. You just draw a vertical line going right through the vertex. Okay? But we might as well, even though that's all we need, we might as well start practicing writing the axis of symmetry equation. Any equation of any vertical line will be x equals, and it will be x equals h. Remember, vertex is hk, so x equals the 0. X equals 0. That's the equation of the vertical line going through the x value of 0, going through the vertex. Are you with me? Yes. Okay. And now for the fun part, part 3, because we know that the a value is 1, we know that it's not going to be wider, it's not going to be narrower, it's going to be this exact parent graph, that exact perfect width, which means that we could use the pattern 1, 1, 2, 4, 3, 9 from the new vertex. So this is how to use the pattern. Check it out. It's awesome. Go to the vertex, go 1 over, 1 up, and put a dot right there. And it doesn't matter if you're going to the left or to the right. You could even go both. But I'm just going to go to the right in this case. 1 over, 1 up is right there. And then you don't, from that point, go. You go back to the vertex. And then you go to the next part of the pattern, 2 over, 1, 2, 4 up. 1, 2, 3, 4. And you put a dot right there. And then you go back to the vertex. And then you go 3 over, 1, 2, 3, and 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm up here on the edge. Are you with me? Yeah. Now you could use a pattern in the other direction. Oh, wait a minute. I'm so sorry. I didn't even write down the pattern. We could use 1, 1, 2, 4, 3, 9, because a equals 1. because the A value is 1. And it's positive 1, which means it's opening up. That's why I went up instead of down. Okay. Now, once you use the pattern 1, 1, 2, 4, 3, 9 to get those coordinates, you could use the pattern in the other direction to get the other points on this side, or even better, you could use the axis of symmetry line, that green dotted line, to reflect it. Symmetry means that there's symmetry. It's the same exact. Left side will be on the right side will be on the left side. So right here, it's 1 unit away from that reflection line, from the axis symmetry line. So if you go 1 unit this way, you could put a dot right there. And over here, 2 units away would be a dot right there. And then up here, 1, 2, 3 units away, 1, 2, 3 units away will be a dot right there. And ladies and gentlemen, we have graphed this perfect parabola without doing any math. We didn't do any inputs or outputs. We didn't actually do any math whatsoever. We just learned how to look at this in vertex form, identifying H and K. And then we also know that the A value of 1 provides us the pattern 1, 1, 2, 4, 3, 9 because it's A equals 1. If it would have been a negative 1, it'd just be the pattern but going down instead of up. Let's take a look at this guy right here. Let's do the same exact steps, same process. Step 1 is what?
Vertex.
And what is a vertex?
2, 0.
Think opposite, and K, take it for what it is. Think opposite of there, that's why it's 2. Plus 0, there is no number being added at the end, that's why the Y value is 0. The H is 2, the K value is 0. The vertex has a 2, 0 for the X and the Y on the vertex. Anyways, step 2. What is step 2? Axis of symmetry. Let me abbreviate here, A of S. Okay, and wait a minute, let's graph 2, 0. That's a vertex. I'm sorry, I got ahead of myself. Once you get that vertex, graph it. And now we talk about axis of symmetry. Visually, this is it. Just draw a vertical line right through it. You don't really need the equation to graph, but we might as well practice writing the equation, which is x equals h, which in this case is the 2. And now we could use the pattern 1, 1, 2, 4, 3, 9 because we have the A value of 1. We could use this pattern if it's 1 or if it's negative 1, but if we have a 2 right here, we could no longer use this original pattern anymore. That would make the parabola narrower, which would change the pattern altogether. So right now this week, we're only working on A values of 1, which is the pattern 1, 1, 2, 4, 3, 9. So from this dot, am I going to be going up or down? Up. So it's 1 over 1 up, 2 over 4 up, 3 over 9 up from the vertex every single time. So 1 over 1 up, put a dot right there. Go back to the vertex, 2 over 4 up, 1, 2, 3, 4, put a dot right there. And if I did go 3 over 9 up, I'd be off the graph. I don't have to graph it. It does exist. It's there. It's just off of this small graph. So let's now map them over to the other side of the axis symmetry equation. The line, that green dotted line right here and up here, and we're done. Connect those dots. It's not a V, it's a U-shaped curve, so make sure you curve it a little. Put some arrows on it, and you are good. Not bad, huh? Okay. Oh yeah, I've been forgetting. On all of these, I may ask you to state the domain and range, right? Now, the domain for any absolute value function, which is a V, or any parabola, which is a U-shaped curve, it doesn't matter if it's opening up or down, if it's wide or narrow, it's going to be x equals what?
All real numbers.
That's right. So that's like a free point, right? Now the range, the up and down, yeah, you got to know where is. Okay, so look at this parabola right here. The vertex is either the maximum or minimum point. In this case, it's the lowest point. And what y value does your vertex have? It has the y value of negative 4. So this whole entire parabola is at negative 4 or above. Y is greater than or equal to negative 4. How about number 2? What's the range on that one? Y is
Greater than or equal to 0.
greater than or equal to 0. That's right. Because in terms of the vertex is negative 2, 0. The y value of that vertex is 0. It does exist at the y value of 0 and above. So y is greater than or equal to 0. Okay, I'm not going to be doing the domain and range for all these, but I do want to explain how to graph all these, right? So number 3, step 1 is to find the vertex. Okay, now it will definitely help you, especially you guys are beginning doing this right now with vertex form, to put parentheses around the x only. If you don't see any parentheses, put them in there. It'll help you. And now you should be able to conclude that your a value is what? -1, which causes it to go down. Your h value is what? 0, because there is no number being subtracted from x inside of the parentheses. And your k value? 0. So we know that our vertex is 0, 0. Put that dot right there. Step 2 is to do your axis of symmetry, is simply the vertical line going right through that vertex. And that's all you need to graph, but just for the sake of practicing of writing the equation of the axis of symmetry, we're always going to write x equals the x value of your vertex, which happens to be 0, because that will be a question itself on the quiz and on the test next week and the week after. And finally, we get to do the pattern from the vertex. The only difference is this a value is -1, which means that we could still use the pattern 1, 1, 2, 4, 3, 9, but we have to use it opening down instead of up. So when I say 1, 1, I'm not going 1 over 1 up, I'm going 1 over 1 down. So I put a dot right there. Go back to the vertex, 2 over 4 down, 1, 2, 3, 4, put a dot right there. And of course, if I went 3 over 9 down, I'm way off the graph. I don't need to worry about that. It does exist, it's just not showing on my tiny graph. And I could map it over to the other side right here and right there. And guess what? I am done. Put some arrows on it. You're good to go. Okay. Same thing. I forgot the domain and range. You know, we'll get to the domain and range later. How about number 4? What's the vertex? 0, 5. 0, 5. I hope everybody sees that. If you don't, put parentheses around that x. That way you could be like, oh, okay, what is the h value? Oh, there's nothing being subtracted from x, so that means that the h value is 0. What's the k value? It's +5, so leave it as a +5. Okay, that's step 1. Finding the vertex. Let's graph it. 0, 5 is way up here on the edge. Step 2, axis of symmetry. That would just be to draw this green dotted line, which happens to be your y-axis right there. But if I wanted the actual equation, like if the question said, what is the equation of the axis of symmetry of this parabola y equals -x squared plus 5, the equation will be x equals 0, the x value of your vertex, the h value, right? And last but not least, the pattern is 1, 1, 2, 4, 3, 9. But because it's a negative a value of 1, it's going to be going 1 over and 1 down because of it being negative. 1 over and 1 down. If it were positive, I'd go 1 over and 1 up. But it's negative, so I go 1 over and 1 down. And then I go back to the vertex, 2 over and 1, 2, 3, 4 down. Then go back to the vertex and then go 3 over, 1, 2, 3, 9 down. That'd be right here. And we're going to map them over to the other side of the axis of symmetry right here, right there, and right there. But how did I do it so fast? 1 unit away, there it is. 2 units away, same level, 2 units away, same level, 3 units away. You have your parabola. We graphed it without doing any math, guys. Let me use the red. We didn't use any math. All right, since we were mentioning domain and range, we know that the domain for any parabola is x equals all real numbers. Guys, what's the range of this guy right here? What's the range?
Y is less than or equal
to 0. Okay, and the other one, y is less than or equal to 5. Perfect. Okay, last two. You know what? I'm going to pause it right here. I want you guys to work on it, and then I'm going to walk around, see if you guys got this, and then I'm going to explain it in a couple of seconds. I'm pausing right now, and then I'll jump to explaining in a couple of minutes. Check it out, guys. Step 1 is to state your vertex, and the vertex is, you think opposite of that, which is +1. You take that for what it is. That's -3. So the vertex is +1, -3. If you go to +1, -3, you should end up at that coordinate right there. That's the most important point of this parabola. Okay. Now we're going to do step 2, the axis of symmetry. That's simply a dotted vertical line going right through the vertex. Wherever your vertex is at, you're going to do a dotted vertical line right through that vertex, wherever it's at. Okay? So from that point, oh yeah, by the way, just for funsies, what is the equation of that green vertical line? X equals 1, the x value of your vertex. Okay, so I will ask you a question like that on the quiz. What's the axis of symmetry of this whole thing? You would just say x equals 1. Anyway, moving on to part 3, using the pattern of 1, 1, 2, 4, 3, 9. The a value, as you could see, is positive 1. It's an invisible positive 1. So I will be going 1 over 1 up, and I'm going to put a dot right there. Go back to the vertex, go 2 over 4 up, 1, 2, 3, 4, put a dot right there. And last but not least, 1, 2, 3 over 9 up, 1, 2, 3, 5, that's 8, 9, I'm off the graph. I don't need to put that dot that's off the graph. If I want to, I could, but I don't need to. Anyway, let's reflect these red dots to the other side of that green axis of symmetry. That would be right here and up here. Again, it's 1 unit away, 1 unit away, 2 units away, 2 units away. Now, the other dot was up here, which was 3 units away, which 3 units away this way would be up here. But I don't have to put those because they're off the graph. Anyway, here's my parabola. Here's my curve. And that's it. Last one. Hit me. What's the vertex? Negative 2, 4. Let's graph it. Negative 2 on the x, 4 on the y. Right there. And what do I do next? That was first step. What's the second step? Axis of symmetry. And what is the drawing? It's easy. You just draw it. And in reality, when you're graphing, that's all you need to do. You don't really need to state the axis of symmetry equation, but I want you to state the axis of symmetry equation. What is it? X equals negative 2. Whatever your x value of your vertex is, that's what you write. X equals that h value. And finally, pattern 1, 1, 2, 4. This is part 3, by the way. 1, 1, 2, 4, 3, 9. And it is opening down because your a value is negative. So 1 over, 1 down. That's right here. Go back to the vertex, 2 over, 4 down. That's actually at the origin. Pretty cool. And then we go 3 over, and then 9 down. That's 4 plus 5. That's 9 right here, right on the edge. And then map them over to the other side. This is 3 units away. So 3 units away would be right there. This is 2 units away. 2 units away over here would be right there. And last but not least, 1 unit away. Here's my parabola. Once again, guys, I don't know, I don't think that you guys are amazed, but I'm amazed that we're able to graph these parabolas without doing any math, right? If you know vertex form, you could identify your h and k. You could understand that the a value of negative 1 or positive 1 produces that pattern 1, 1, 2, 4, 3, 9. And knowing the axis of symmetry, you could reflect the coordinates and graph parabolas in a matter of seconds.